Okay, so this is the electromagnets lab. I'm Betty Yu, and today's date is June 27th, 2014. So the point of this lab is to create a strong electromagnet. So what you need is 3 to 4 feet of insulated copper wire, an iron nail, which will be the core of our electromagnet, a power source, so a new D battery, it's the big kind, 2 small compasses, but I don't have small, I have quite large ones, but I guess that's okay, and electric tape, and finally paper clips. Okay, so basically I'll be showing this, and even though there's only procedures of how to make your magnet and not what to do with it, I'll try to, Okay, so to make your magnet, what you have to do is wrap a wire around your nail. So you have to leave 6 inches off each side, so let's do this. So I'm gonna leave 6 inches and start wrapping it around. Okay, just keep on going, make it nice and tight. So this might take a while. Just sit back and be patient, please. I should have done this beforehand. Okay, that should be good. So I'm gonna run and get some scissors real quick, so I'll be right back. Okay, so I'm gonna leave 6 inches, so let's make it about this much. And cut it off. So we have this. And it says to cut off at least, let's see, 2 centimeters, so 1 and a 2. Okay, so attach the wires to a battery source. And then, what we're gonna do is attach it to the battery with the electrical tape. So just peel some off. So attach one end to the negative side, like so. And then one to the positive. Oh. Hang on. Okay. Right over here. Tape it nice and tight. Oops. Ugh, this tape. Let's add more tape so it can be more in place, you know? Here as well. should have your electromagnet. So what we're going to do next is go on with the procedure. Okay, so first let's answer the questions, and on the way we can test out the electromagnet. Okay, so the first question is, what could you do to quantify the strength of your magnet? Well, 3 factors that we learned in the videos to affect the magnitude of the induced current is the number of loops in the coil. So that means as the number of loops in the coil increases, the magnitude of the induced current also increases, because more loops cut through the magnetic field lines. And another factor is the strength of the magnetic field. And the third one is the speed of the relative motion between the magnet and the wire. So yeah. So what end is the north pole of your electromagnet, and okay. So the south pole, I'll fix that. So the south pole would be the flat end, right here, while the north pole would be here. So the north pole should be connected to the plus part of the power load of the source of power, and then the south pole should be connected to the negative side. So the way the current is moving through here is just like they move from positive to negative. So it goes from here, travels to here, and goes to negative. So in this case, this would go clockwise. Okay. What could you do to reverse the poles? Let's see. So if you were to you can reverse the connection by changing both ends of the wire to the opposite sides of the battery. We can do that on the way. And then when the direction of the current is reversed in either a coil or electromagnet, then the magnetic poles reverse as well. The north pole becomes south and the south becomes north. And then we will use a compass to measure. Okay, it doesn't give exactly what to do with the directions on lab doesn't exactly say what to do with the compasses. It only says what to do with the paper clips, but I think I have a general idea what we're supposed to do. So let's measure our, if I can open this thing. Never mind, I'll just use this one. Okay, so watch. So you see the compass? You may not see it, but I'll try my best. So if we place it on top, it's okay. And then, but if you place it on the bottom, sorry, this isn't connected. Okay, so if I put out my palm like this, that way is north over there. So if I place it above it, the compass wobbles a little bit. It goes this way. Yeah, you see it wobbles. We do this, and here you can see that it wobbles. But if we put it at the bottom, sorry, this is kind of acting weird. There we go. Okay. Yeah, you can see it turning, right? So it turns towards east in this point if we put it at the bottom. Yeah, see, that's a really big change. But if you put it on top, I don't think it does really anything on the top. Well, it turns it like wobbles a little bit to the east, but it's okay. So that's what we do with our compass. And now watch as we use our, well, we're gonna see if we can pick up any paper clips. So let's see. I don't think mine can yet. Yeah, so mine's not strong enough to pick up any paper clips. But what you can do to make the paperclip, the electromagnet stronger so that it will pick up paper clips is you can either, like I said earlier, you can intensify the number of coils in here. So I can just add more coils to intensify the attraction. And we can also change the core. Like iron isn't the only thing you can use for the core. You can use any ferromagnetic material you can have. And maybe the source could be stronger, maybe a bigger battery if that's possible because it's pretty big. And yeah, but we can see what it does when it's, okay, so we have a hanging paperclip here. And what we're going to do is, like, see, if you go here, you see it, the bottom starts to wobble. And I can feel it all the way from up here wobbling. And over here, it starts to twist and turn even more. And over here, same thing happens. And then finally, so yeah. So if you put an electromagnet next to a bunch of dangling paper clips, they will start to wobble. Okay, so now we can change reverse. So the south pole goes to the positive side, and the north pole goes to the negative side. So we'll see what it does to the compass. Stick. Okay. So when we put the compass under the the one we did before, it went to the east. So let's see which way it goes here. So the compass is pointing that way. So if you put it here. Okay, so this time it's turning to the west. Do you see that? So if we don't put it over here, it returns back to normal, which is to the, yeah. So if we put it over here, we can see it going to the west quite a lot. Okay, and remove it. And let's see what happens when we go on top. When we go on top, it goes to the east, yeah. So it's more evident here than on the last one. So when we put it at the bottom, it goes to the west. And when we put it on the top, it goes to the east. So let's try the clip thing again. It should have the same effect though, so let's see. Okay, so I guess it's still not heavy enough to pick it up. Same reason. And then if we use this, let's try to see, it starts wobbling. And then this one starts wobbling. Okay, okay. See, they're wobbling pretty much. It's not me that's shaking, I promise. It's the electromagnetic. I can feel the force just by holding it next to it. So yeah, I've made, and I broke, a successful electromagnet. So yeah, I will answer the questions and put them in the Dropbox, and I'll email this video to you. Thank you for watching.